Hi, welcome back to my channel Daily Code Dive. So today in binary tree series, I'll be explaining post-order traversal of tree. So what exactly is post-order traversal? Okay, so like any other traversal, like in order or pre-order traversal, this is one of the technique to traverse through tree. So here in the post-order traversal, it will follow. It will basically start to cover left subtree and then the right subtree, and then at the end it will cover the root. So it's like it will follow this policy where left child, left, then right, and then root. So here it will basically follow the left subtree first, and then the right subtree, the left subtree first, okay, then the right subtree, and then the root. So whenever we are writing any post order traversal, our first preference will be, so let's suppose I am taking this subtree, okay. So here also we'll first take the left child, then the right child, and then root. So this is the post order traversal of this left subtree, okay. Then after that, if we am taking let's suppose post order traversal for the right subtree, what it will be? It will be first, so here we do not have any left child, so we'll take right child 6, then root is 3, and then the ultimate root of both these three will be 1, right? So 1. So this is the post order traversal of this complete tree, okay. So now this is how we can find the post order traversal, but if we want to easily find it in a shorter span of time, how we can find the post order traversal of any tree, okay. So now that I'll be explaining now, okay. So for that, the same technique which I have explained for the pre-order traversal and in order traversal, I'll be using the arrow technique. I'll draw arrow with all the trees node, okay. So with all the nodes I'm drawing these arrow. If you remember, these arrows are actually exactly opposite which we have drawn for pre-order traversal, okay. So now what we will do, we will start traversing node one by one. We'll start it from here. Do we got any have we got any arrow? No, right? So we'll move further. Do we got any arrow? No. Do we got any arrow? No. We got? No. Yes, here we got. So 4 will take. Now again we got any arrow? No. Till we reach here we got one arrow, so we will take 5 as well. After that we will go here, we got 2. Now here no, we got here when we reach 6, so we have taken 6 here. Then after that we reach here 3, we got 3. Now we reach 1 and we got the arrow as well. So this is the post order traversal of this tree. You can easily use your fingers for finding these post order traversal values or the result, okay. So now I'll be explaining the algorithm part of this of the code, how we can implement it in the code. It's very simple, and it's actually very much similar with the how we have traversed pre-order traversal, how we have implemented the algorithm for pre-order traversal. So I'll write the output for the reference. The output will for the post-order traversal will be 4 5 2, then 6, then 3 1, okay. So now I'll just take one stack. One by one, what I will do, I will insert the element and I will pop out from the stack. So first element which we will have, so before that, before even pushing inside the stack, first thing which we have to do, we first have to check whether the root is null or not. If it is null, we will obviously return no result. If it is null, we will not result any result. If it is not null, we'll first push it inside the stack, okay. So for the result list, let's suppose we have a vector list, okay, a list which will store the result, okay. So initially what we will do, we will pop out 1 from the stack, we'll store it here in the result list, and after popping it out we'll check does it have any left and right child or not. So here the main thing is the order of pushing it inside the stack. For pre-order traversal, what we do, we'll first push the right child and then the left child. But here in the post order traversal, most important, for the post order traversal, what we will do, we will push the left child first and then the right child. Okay, so left child first and then the right child. Now what is there inside the top of that element or top of the stack? We have 3 in the top of the stack. So we will pop out from the stack, we will place it inside the result list, and now what do we have as a child for 3? We have 6. We will push it here. We have removed 3 from the stack. Now what is the top element of the stack? That is 6. We will pop it out and we will place it inside the vector list. Okay, and of course 6 does not have any child node, so yeah, that is it. Now what comes next? That is 2. Okay, so 2 we will insert here, and then after that we'll first place the right child, left child, and then the right child. So yes, so now what comes at the top of the stack? That will be 5. We'll pop out from the stack and we'll place it inside the result list. The same procedure again, similarly for 4 as well. So this is how we got the result list. Now if you can relate from the original, the answer, that is, if we reverse this result list, we'll get the post order traversal. So what we will do, we will simply apply this function reverse for this vector list, and if we reverse it, 4 5 2 6 3 1, this is our answer. So this is how you can easily implement the post order traversal using stack. Now we'll take one lead code problem to basically get the post order traversal of a binary tree. So yeah, let's go towards the problem now. So here I have taken one lead code problem where we have to basically find post order traversal of a tree. Here are some example. So you can see we have taken one tree, like it's the structure of the root, they have given the input like this, and then they have got the post order traversal as output, that is 3 2 1, right? So this question I have already solved on the lead code. So now I'll start explaining the similar way I have explained in the algorithm. When I was explaining the algorithm, same thing. So first thing in the algorithm, what I have taken one stack, right? So that I have initialized here. I have taken one stack here. Okay, then after I also have one vector list I have taken, that will only store the values of the nodes. Okay, then first thing, so first check what we will do, whether root is null or not. If root is null, in that case we will return the empty list, because yes, if it is null, then nothing is there, right? Then after that, what we will do for second thing, that we will first insert the first element inside the stack, that will be the root node, and then from here onwards we'll start the loop. We'll take one loop and that will iterate based on the condition that the stack is not empty. As soon as stack is empty, we'll stop there, right, as we have explained there in the algorithm part as well. Okay, so here first thing what I am doing, I'm basically taking the top element. So there's a variable called node, which is of tree node. Okay, so it will basically get the top element from the stack, and that element I will push it inside the result list, that value of that node. Okay, here I am pushing it here in the line number 21. After that, whatever the top element, I am basically removing it from the stack, and then again I am checking if the left or right child are there, then I am simply pushing it here inside the stack. So with that, this loop will basically go on, continue until and unless we are getting the stack as empty. And after that, so now everything we have stored inside the result list. In the end, what I have explained, that we basically will reverse the result list and then we'll get our answer. You can see here as well. So I'll again compile it again, maybe So with all the three cases it's passing, and even when I'm submitting it's passing for all the cases. So this is a very simple code and very simple approach you can basically apply to get the post order traversal. It's similar like what we have done in pre-order traversal, but for pre-order traversal what we will do, basically we'll first insert the right child. You can see here, if you see here, line number 24, I have inserted the right element after the left element, right? But in the pre-order traversal what we will do, we will first insert the right child and then the left child. And of course in the pre-order traversal we are not going to reverse the vector list. Here we are reversing, so it's similar to pre-order traversal, how we have traversed through pre-order. But yeah, the ordering of the how we are basically inserting the element, the left and right child, that matters here. That's it. So yeah, so thanks for watching this video, and I hope I'll be able to explain post order traversal. Do let me know if you find any difficulty, and if you have any better way to get the post order traversal. So yeah, thank you so much for watching this video.